Click the bell icon to get latest videos from Ekeeda.
Hello friends, let us continue with the type of questions we have been solving, that is finding FA, RE and RG, that is finite automata, regular expression and regular grammar for various questions. Over here in the first question, we are trying to find the regular expression, regular grammar and finite automata for the set of string which ends with 0 over the binary string language. First, let us try to construct the finite automata. As you can see, I have used two states, Q0 and Q1. On Q0, we are waiting for the string to reach the end. That is, we are skipping the symbol 0 or 1. On the arrival of last 0, we will have a transition from Q0 to Q1. Over here, Q1 is a final state and hence it will accept the set of all strings which end with 0. Now, let us try to write the regular expression for the same language. The structure of the regular expression will be a number of zeros or 1 followed by a 0. If we try to use a clean closure, the expression would be 0 or 1, 0 or more number of times followed by a 0. That means the minimal string accepted by this language is a single 0. Now let us try to draw the grammar for the same language. Here there are two non-terminal symbols used, S and A. The terminal symbols used are 0, 1 and an epsilon. Let us try to analyze the grammar. The grammar saying the first product. The grammar says that the first production S produces A0 will produce a 0 at the end following A. And what is A producing? A produces 0A, 1A or epsilon. That means A will help us in producing a number of zeros or 1. That is exactly in the regular expression 0 or 1 star. And after that, S will produce a 0. If we try to draw the parse tree for the various strings which is generated by this particular grammar, you will see that the smallest string that would be generated would be the same as the one shown by tree 1. That is the string 0. The next smallest string would be the string 00. Similarly, you can produce 10 and various strings, but you will always see that the end would be 0. Because of the production, S produces 0 at the end. With this, we have solved a question in which we are trying to find the regular expression, finite automata and regular grammar, and we have even considered the parse tree for that particular language which contains the binary string which ends with 0. One more thing that you can note from the regular grammar is that we are using one non-terminal at a time, and these grammars are called linear grammars. Over here in the second production, we can see that the non-terminal A is repeated at the right hand side, and the linear grammar in which the terminals are repeated at the right hand side is also called right linear grammar. We have already discussed that regular grammar are those grammars which uses either right linear production or left linear production. Now let us try to solve one more question. This question is asking to draw us FA, RE and RG for the set of strings over binary alphabet which starts with 10. As you can see from the picture, the states that we are using is Q0, Q1 and Q2. This FA accepts the set of strings which contain 1, 0 followed by any number of zeros or ones, which is exactly the language which was asked in the question. Now let us try to draw the regular expression. In the regular expression, we know that the starting symbol should be 10. Now this 10 must be followed by any number of zeros or ones. Hence, the regular expression should be 10 followed by 1 plus 0 the whole star. Or one more way to represent the regular expression would be 10 followed by 0 or 1 the whole star. Now let us try to solve the third question, that is finding the regular grammar for the same. You can see that the grammar contains two non-terminal S and A and terminal 0, 1 and epsilon. What is the first production doing? The first production produces 10 and the non-terminal A. A help us in producing any number of zeros or 1, which is exactly the part 0 plus 1 the whole star in the regular expression. Let us try to analyze and draw the parse tree for the given string. Now, let us try to find out the parse tree for the string accepted by this language. S is the start symbol. It is having 1 0 at the first production. After 1 0, we will have the non-terminal A, which may produce at least epsilon, and hence the minimal string produced by this language is 1 0. If we try to expand the string using productions of A, we will see that the next set of string which might be produced by the grammar would be 1 0 followed by a 0 or 1 0 followed by a 1. Similarly, this grammar would generate all the string which starts with 1 0. Again, you can see that this grammar is right linear, that is, it has the non-terminal at the right hand side. In the first production, A comes in the right hand side of that particular production. Similarly, even in the second case, the non-terminal A comes in the right hand side. We have solved a few questions on finding the finite automata, regular expression and regular grammar for a few simple questions. From the next video, we will be continuing with the same for a more complicated questions. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.